All right, how you guys doing? This is Mr. Vaughn. I just want to welcome you to our class. We're learning some algebra. Just make sure you click the link in the box below and it will give you the notes to all of these lessons, all right? So today I'm really excited because I want to show you a real life example of using systems of equations, because a lot of times we can get in all this algebra and we can wonder, gosh, this just seems so academic, so irrelevant. When would I ever use this stuff? Believe it or not, you can use this stuff, right? One time I was in a board meeting for a church and they were discussing, they were unhappy with their current alarm system. They were paying, and I have it right here. This is pretty much, the numbers are pretty close. They were paying like $155 a month for their alarm company, but they weren't happy with the service. The alarm would go off and no one would respond. And so they were looking into getting a new system. So they checked out another system and they got quoted $55 a month. However, it was going to be an initial startup fee of $1,500. Okay, so the current one was $155 a month. They got a quote for $55 a month with an initial startup fee of $1,500. And so the question on the board members' minds were, okay, how many months until we start saving money, right? Is it worth investing in this new alarm system with this really big initial startup fee? I was in that meeting and I was able to use substitution, solving systems of equations by substitution, and in minutes I gave them an answer. Real life situation. All right, and so that's what we have right here. Okay, so the first thing we need to do when we are trying to, when we have word problems, we need to learn how to read word problems with an algebra mindset. All right? And in order to do that, I showed you that the first thing we need to do is we need to define the variables. What is it that we're talking about here? Well, we're talking about what? We're talking about dollars, right? We're talking about money. What else are we talking about? Well, we are talking about alarm companies, but what relationship, do you see the relationship with money? What item is related to the money? The time, right? It's so many dollars per month, right? So we're talking about dollars and we're talking about time. So that's our two variables. Once you find those two variables, you're home free. All right, so I'm going to go ahead and define my variables right over here. So I'm going to let, what should we use for money? We could use M, we could use D for dollars, we could use C for cost. How about cost? In fact, let's put this over here further. We're going to let C equal cost of system. I call this alarm systems of equations. Okay, let C equal the cost of the system. Okay, now the other thing is months. Okay, we could use M for months. For any sort of time, I like to use T. Okay, so I'm going to say let T equal time in months. Okay, so you could use different letters. That's totally up to you. The main thing is, hey, we're talking about money, cost, and we're talking about time in months. All right, and now we have our variables set. Now we can set up an equation. Okay, remember in one of our videos just recently, I showed you the slope-intercept form. Remember that? And I said that y equals mx plus b. Remember that? Where m was the slope and this was the y-intercept. Okay? I'm going to show you how this formula, this form, relates to real-life situations. Okay, the slope just means, right, if this is a slope, the degree of slant. So this is a little bit of slope, more slope, a lot of slope, right? So slope is just the rate of change, how fast something's changing. Okay, what do you think would be our slope in this problem? Would it be the cost or would it be the time? What is it that is, what's the rate of change? Well, the rate of change is the cost, right? You can go $155 a month or you can go $55 a month. Okay? This y-intercept is just a constant at the end of your equation. That's going to represent a lump sum, right? So if I said, hey, you're going to earn $10 a month, or $10 an hour, plus $100 at the end of the month, right? That $100 is just going to be kind of lumped into your rate, okay? So this is going to be kind of like my lump sum. It's going to be the amount added at the end. And the slope is going to be my rate. Okay, so if you can think of this slope-intercept form as y equals the rate times the variable plus some lump sum. All right, so let's use this idea and see if we can develop two equations with our two alarm companies. Okay, let's go ahead and develop an equation for security blanket alarms. By the way, I just made that up. Kind of a cool name. Security blanket alarms. So I'm going to say SBA, right? Security blanket alarms. Let's go ahead and develop an equation for them. Okay, y. So instead of y, I'm going to use cost. What's my cost? My cost is, right, my rate. What's the rate? Well, the rate is $155. So my cost is $155 per what? Per month. So that means my T is going to go right there. So if T is 1, right, after 1 month, I'm going to pay $155. After 2 months, right, see, I just multiply 2 times 155. And it gives me 310, I believe. Okay? So there's my equation for security blanket alarms. See, the cost is $155 T. All right. How about my equation for American alarm systems? So American alarm systems. Okay. So we have, let's do a different color. The cost of this system is going to be what? What's the rate of this system? It's much lower, isn't it? That's what makes it attractive. It's only $55 for every month. Okay, but is that all? Well, if that was all, that would be a no-brainer, right? It's like, yeah, let's switch right now. We're going to save $100 every month. However, there's more to this. There's a startup fee. See, that's the catcher. I have a startup fee of $1,500. Right? So right off the top, as soon as you say, okay, we're going to get this alarm, as soon as they start their work, they're going to charge you $1,500. It's a one-time fee, right? Because they got to pull all the other old equipment out, and they're going to install their own equipment, right? So there's an initial startup fee. That's going to be my lump sum thrown on the end, right? So I'm going to add $1,500. All right, so there's my equation for American alarm system. The cost is $55 per month plus $1,500 to start. Okay, and the question is, when will the church start saving money with the new system? What do we need to find? Do we need to find C or do we need to find T? Well, let's see, how many months? That's a question of time. All right, so we need to find T. Well, how do we find T? Well, I have a system of two equations, don't I? And I have two unknowns. So if I have two equations and two unknowns, I can solve this. All right, so if you remember substitution, C equals 155T. That means everywhere I see a C down here, I can substitute 155T. Okay? So in fact, what I'm going to do is I'm going to take this 155T and I'm going to substitute it right into that C. Because that's what C equals, is 155T. Okay, so let's bring that down. So C, and what's C? C is 155T. So I got 155T. That's what C is. Okay, it says it right there. Equals 55T plus 1,500. Now look at this. I have one equation, I have one variable. I have a T in two different places. I can solve for T. Okay? Equation solving skills. I don't have any distribution to do. I don't have any like terms. So I can go straight into my addition principle. I am adding something. So I like to get my T's on the left side. Okay, so 55T, I don't like him here on the right. I want him over here. So how do I get rid of a 55T? Well, I just subtract 55T. Just make sure you subtract it to both sides. Okay, and that's going to cancel on the right. And 155 minus 55 is what, 100? So you get 100T equals, that's gone. I'm just left with 1,500. 100T equals 1,500. All right, now this is multiplication. The inverse of multiplication is division. So I'm going to divide by 100 to both sides. 100 divided by 100 is 1. So I get 1T, or just T. T equals what? Let me show you a really cool shortcut. When I have 0 on the top and 0 on the bottom, essentially I just divided by 10 on the top and bottom. Look, and I got another 0. I can get rid of those two. So my answer is 15 over 1, or just 15. Okay, 15 what? 15 months. All right, T equals time in months. So you're sitting there at the board meeting, and they're trying to figure out, oh man, should we get this new system? How long is it going to take us before we break even? Hey guys, I got the answer. And by the way, this actually happened to me in the board meeting. I said, hey guys, it's going to take us 15 months. After 15 months, we'll start saving money. So they said, oh wow, that's really cool. Okay, let's go with the new system, they said. All right? See, the power of mathematics. And you know, if let's say they asked this question, hey, how much money would we spend after the 15 months? We could find that too. It's not in this problem, but if we wanted to find out how much money we'd have forked out by the time we started saving money, easy enough. I just substitute 15 into either one of these. This one's easier. So 155 times 15. What is 155 times 15? Just this is a curiosity part of this problem. 155 times 15 is $23.25. So we would have spent, our cost would have been $23.25, over $2,000 by the time we start saving money. All right, so if we're in it for the long haul, we definitely want to go with the new system. Okay, so I hope this was helpful. I know it was a little challenging to develop these equations, but once you can start thinking algebraically and doing the translation, this becomes pretty easy. All right, I want to thank you for joining me. Make sure you subscribe to my channel, and as always, may God richly bless you.